in our first DoK meetup in London, but today we're back with a super cool Ask Them Anything session with two of our, I don't want to say most veteran, OG community members, Jeff and Patrick. OG. Patrick's so OG that he's in his car right now. It's on his way. Anyway, he'll be joining us very soon. Before we get started, as usual, folks, just basic, housekeeping reminders. We'll be hearing about this in every live stream for the next couple of weeks until our CFP closes. All right. But if you haven't submitted a CFP yet for KubeCon, proposal for a talk, please do so, as long as it meets our requirements regarding talking about running stateful workloads on Kubernetes or anything else that belongs to the data on Kubernetes ecosystem, analytics, AI, machine learning. We're hearing a little bit about that more in detail in the talk from Jeff and Patrick, but please definitely get that in there. Unlike regular live streams in KubeCon, talks are a little bit shorter. Also, we're very much focused on diversity there, so keep that in mind. Also open to panel submissions too, so that's an additional option if you'd like to get into that. But that being said, that's pretty much all I got in the way of an intro or reminders that we have there. Of course, check out the live streams we have coming up next week and the following weeks. But that being said, one of our speakers today is Jeff Carpenter, who's a legend at DataStax, DJ Jazzy Jeff. Soon to be published author, has a real background. This is not a fake background. We were talking before we got started. That's his diploma on the wall. But Jeff, could you just, for the folks that don't know you, although they very much should know you if they have been good attendees in our other meetups,
that's okay.
That involved in different talks. No shame. But who is Jeff? What brought Jeff to Data on Kubernetes? What can we expect today? And hello, Patrick.
Hey. Hi, Patrick.
No, you go right ahead, Jeff. Go.
That really weird link that I just sent you actually worked. That's so awesome. Yeah. Well, okay. So I've been involved in the Apache Cassandra community for 7-8 years now. Coming out of a love that I have for building really, really big next generation applications, which has taken me some interesting places. So having worked with Cassandra for a long time, I began to understand that, like within DataStax, what we were doing to build out a database as a service was based on Kubernetes and deploying Cassandra in Kubernetes. And then we were actually building a product based on that. And as I began to learn things like that, I was like, wow, I'm weak in this area and I need to get to know Kubernetes better and how to run things on it. So about a year and maybe just a little over a year ago, I just dove in with both feet and was like, you know what? Yeah, I'm an imposter on Kubernetes. I'm just going for it. I'm just diving in.
Okay.
So no, that's my background.
No, but everybody has a different sort of path in terms of how they got here, and that's yours. Now, Patrick's path, Patrick was involved, did our very first live stream. It seems like it was 500 years ago, but it was in July of 2020. Patrick, you are here today, and today is no ordinary day. Today also happens to be your birthday. So I've already put out a little message in the chat, but I want to see lots of birthday balloons. I want to see lots of cool emojis flying off in the chat. Today is Patrick's birthday. Very, very special day. Very happy to have you with us. Patrick, you've seen the evolution of this community and the evolution of this sort of question and the challenges of data on Kubernetes. Where do you see where we're at today? And with that as a segue, maybe we can start jumping into the slides that you prepared. Remember, folks, this is an Ask Me Anything session, so get your questions down. You can also get them in Slack. Jeff and Patrick have a quick presentation for context, and then we'll just get right into direct questions. But in the meantime, you can keep them coming in the chat. Patrick, just a little quick overview of where you see we're at today based on where we were at when you did that first inaugural live stream about is Kubernetes even ready for data?
Well, one thing, I'm getting older and I'm learning things.
Good.
And Jeff, if you're teeing up the deck, that'd be great. I don't know. Are you going to present it or am I? Because we got to do that awkward business.
Oh, you talk. I'll do it. It's fine.
All right, right on. So yeah, my background is a little different, actually a lot different, because my world has been infrastructure. I've been doing infrastructure for 20 plus years. And so Kubernetes was just an evolution for me. It was something that was that wasn't surprising. And, I was involved in DevOps, did, the Velocity conference, all that, like back in 2008, 2010, and, moved infrastructure over from bare metal to virtual machines to containers. So Kubernetes was a great evolution. For me, and of course, I've been involved with the Apache Cassandra project for a long time. So cloud native is definitely built into my DNA at this point. But when Jeff and I were talking about writing this book, it was based a lot on that first talk I had at DoK, which was, really, because I think there was a feeling out there in the community that is this, this sounds great, but maybe this isn't the right thing for stateful workloads. And it was just a lot of fear, uncertainty, and doubt. And so when I talked about, that was my first talk, is it? And I posed a few questions, and then like everybody should do, you should answer your own damn questions. So when Jeff and I were talking about writing this book, it was like, this is how we both have a long history of developer advocacy. And this is a really important way of learning is, just digging into a topic. And I think when you read the book and when it's finished, you'll see that we bring a lot of our previous experience into this new world. And it hasn't changed a whole lot. It's just, like, what do they say? Like the future, it doesn't get, or the history doesn't repeat, but it rhymes. So, Chef and Puppet have been replaced by, Kube Cuddle. I'm looking forward to this EMA today, though, because I think it's going to help us. We're halfway through the book right now. It'll help us springboard into the next half and finish this thing strong.
Very good. And that being said, if you're interested in getting more involved in the book, in terms of contributing or asking questions, giving feedback, things like that, both Jeff and Patrick are very, very accessible on Slack. You can reach out and become a part of this. That being said, if you want to start sharing your slides, we can take a look at those. In the meantime, as well, we've got the questions. We've got about 10 or so questions on Slack ready to go, but we can definitely take more. So as this on the go, if you have questions, just drop them in the chat and we'll get to them accordingly.
Hey, which Slack channel are you using, Bart, for this? Is it the meetup one?
The DoK, just the general.
General. Okay, got it.
Yeah, we got a thread. We got a thread starting the general one where I posted different questions from different community members.
Got it. Okay.
Yeah.
Thank you.
Yep. No worries.
Oh, I need the thread.
No, don't worry. I'll link it. I'll send it to both of you right now.
Oh, okay.
Yep.
I see it. Never mind. We're all good.
You got
Everything's
cool.
great.
Good.
I love it. Okay. Here's a presentation called Things We Learned About Kubernetes when writing a book, plus your questions. All right, so you may have seen some of this data before. Basically, everyone's thinking that they are either running stateful workloads on Kubernetes now, or they're going to be. I mean, that's essentially the takeaway from this quote, is that we sense from this great survey that Bart and you guys and the team there, Melissa, Sven, put together and put out last year, everyone's doing it or thinking about doing it. So one of our theses that we had for writing the book, which was, hey, let's show all those haters that Kubernetes is in fact ready. That might not be as tough of a sell as we maybe originally thought. So we did decide to write a book. Patrick's talked about it a little bit already. We're going to show you some stuff at the end here about some concrete ways that you can get involved and help out with this. But if you have an O'Reilly account, you can go onto there and see the book online, the early release edition, with basically about half of the book done. You see our little Tweety bird there that is not the actual animal. They have not even told us what the real animal is, but when will we know? Next month. Yeah. Super exciting. Also, our friends at Portworx had a great time hanging out with Umair and the crew out at KubeCon back in September. And we're so grateful to them for sponsoring this book, which this also means that if you go to their website that you can grab your own PDF. copy of it from them as well. And then we'll show you some stuff on the website later on. So, hey, tell us about the Decoder Ring, Patrick. We're just setting context here, right? What is the Decoder Ring?
Yeah, I think the overall theme that you'll see Jeff and I talking about is what Kubernetes is bringing us in the world of infrastructure, and I think this is what we all need to solve for, is really we're consuming three things continuously. This is the compute, network, and storage. These are the things that cost us money. They have real capital cost. But in any kind of infrastructure play, these are the three things you have to manage. Now, you could say, what about security? What about other things? Well, sure. Those are all important, but these are the resources. These are the things that you consume. This is like, if you play video games, this is like, your mana and your armor and all these other things that can get depleted. We have to maintain.
Are we making Magic the Gathering references?
I may have done that.
May have. Yeah.
I haven't rocked a mana pool in many a year. That's good.
Yeah.
All right, sorry.
And then I have a boost card. Sorry, we're getting a little nerdy. Yeah, so my compute boost is called GPU. These are the three things we rent from clouds, right? And what clouds try to sell us is these three things in some sort of, when you get a bill, this is actually what you're paying for. Yeah, they put services on top of it. So, how do we do this well? Click next, please. And it's moving. This is what we're seeing in our industry right now, is we're moving from this, we're collecting, we're going from virtual servers and containers that we're just, using right now, or we have been using for quite a few years. But eventually what we get is creating a virtual data center. And instead of renting parts of a data center or buying a data center, a physical data center, we're creating a virtual data center that consumes compute, network, and storage in some way, which we can control really well using Kubernetes. And the pods that we deploy in that virtual data center support the application that we want to do. So there's input and there's output, and that virtual data center has everything that we need, including security, but that's a part of the network. So next.
So our whole strategy for the book is basically taking you from these the primitives that represent all these little elements, like going from pods and stateful sets and volume claims and persistent volume claims, building up from these primitives all the way to the point where we have these virtual data centers, and kind of demystifying it along the way.
Yes. And so first thing we learned here, I'll take this when you get the next one.
Absolutely.
And I want to qualify this. I just said this earlier today. Bart's going to say, yeah, I heard that already. When we talk about data on Kubernetes, we're not saying databases on Kubernetes. Okay, that there is more to it, and we'll get to that in a minute.
We are saying
analytics,
but we're saying more than that.
We're saying it's not just databases, it's every bit of your data stack. It's like the analytics, the streaming, the ML, AI, everything. But some of the fundamentals, like where we are today, we need databases that run in, and that we're underlying the in, not on. And there's a really big significant difference in it. If you think about like what the difference is, it's about just installing an application on top of Kubernetes, an existing piece of infrastructure like a database. Sure, but you have to use operators and do a lot of translation and things to make it work. The one that works in Kubernetes actually exploits parts of Kubernetes to make it so that you don't have to include all the everything in there, and then
bring your own Zookeeper and etcd and
yeah. It's just ridiculous. And this is happening. We're starting to see TIDB is one that's done this quite well. There's things happening in the Cassandra project that are going to be released, I think, soon around this as well. So it's happening, but this is just an efficient.
What a tease that was! Wow.
Oh yeah, stay tuned. Cassandra project is going in. Yeah. we can keep moving, I guess.
So one of the things that we're doing with this book is, like I said, kind of putting the word out to people that are maybe have some doubts or some hesitations about running any part of their data stack on Kubernetes, right? Is it ready? Is it not ready? We've already established people seem to think that it is ready and they're moving there. What we wanted to do with the book in particular is highlight and give shout outs to places that we think are mature, and also shine a spotlight on some things places that we think there's probably still some growing to do. You're going to see a couple of more of the growing to do parts in a minute, but we really want to celebrate what's been going on with storage. This is an area that is super mature within Kubernetes. Not that there isn't features to be added and enhancements to be made, but there's a thriving ecosystem of open source projects and extensions, as well as commercial offerings that build on top of those open source. So it's a really cool ecosystem that's developed there. We feel like that's solid and mature. However,
yeah, well, I think this is an everyone problem. If you're not aware, pick any infrastructure you want to run. Say MySQL, just say that, and then go look and see how many operators exist. I know in the Cassandra project where Jeff and I are greatly involved, I think at one point we counted something like 18 different operators that were available on GitHub. It's easy to write an operator. Very easy. And
probably easy. 6 of them were actually active and somewhat viable, right?
Yeah, and well, it's part of the thing where an operator is easy to write to scratch the particular itch that you have, but a general purpose operator is much more difficult because you have a lot more breadth. And I think this is a problem in this industry, that we have too many operators and no indicator of like the quality. There's Operator Hub, which it does a really good job of trying to rate these with these, like operator capabilities and
maturity levels.
The maturity levels.
Yeah.
And like it's nice to have that, but there's not a lot of standardization around, especially around data operators. And so I think this is an area for growth.
Quick question. Just since you mentioned earlier about in and versus on, we got someone asked in the chat here, is it storage on Kubernetes or is it storage with Kubernetes?
That's a with. Yeah. Yeah. If you look at CSI, the container storage interface, that's an in. An on would be, just taking some legacy storage product and slapping it in there.
Yeah. I think it gets a little more nuanced, I think, because, with storage, a lot of times it's actually the storage resources themselves are not, the computers, the actual boxes on which the storage resides are not, part of the Kubernetes cluster. Like, maybe you're using S3 as a backup or something, right? So like when we talk about for storage in particular, when we're talking about in or on, I think a lot of it has to do with where is your control plane running. The more of your control plane for your storage solution that's actually running within Kubernetes cluster itself, I would say the more cloud native you are, and the closer that you are to be to have a solution that's running in, not on. That's the Jeff hot take.
Good. That's good.
Do you want to say anything more about
no, we should move on. Let's move on.
You don't want to talk about the one operator, it's the unified theory of operators? We could do that later. Maybe somebody will ask that question.
Yeah, one operator to rule them all. That's a hot one. Yeah.
Yeah. That only leads to Mordor.
Do you want to talk about, are there any supporting details from the slide that you want?
Oh, yeah. Sorry. As we did have support. And we're not just talking here, we have evidence. Yeah, this was shameless plug for the DoK survey, which was fantastic, and we can't wait for the next one. And if you need to go see all the data, it's on the DoK.community website. But this was a really particularly interesting slide that showed, this is the survey results that showed that the folks that are actually doing a lot of data work on Kubernetes, this is their number one problem. And it's this lack of quality operators. And it's sure, if you were not very scrutinizing and just picked up the first random operator you found for whatever technology you're using, you may not like it because it was made probably for someone else's problem or a very specific problem. So again, this is just, I think, a good data point that shows that this is something that we really do need to work on as a community, is like, how do we get better at building operators, especially for someone who's new?
Right. That's, I mean, this is the way that open source works though, right? People that are, because Kubernetes is open and so easy to extend, assuming that you know Go, then anyone can write their own operator to control different aspects of things. And then the problem is, am I able to gather a group of people around the data infrastructure that I care about so that we can together build a high quality operator that solves everyone's use cases? That's a little bit of a bigger problem.
Yeah.
Which is why writing operators is hard.
Yeah. Well, go ahead, Jeff.
I was going to say, I probably gave the spiel before I advanced the slide.
Yeah,
but,
you did.
I do think, maybe another way to say that is writing operators is deceptively simple, because getting the initial part of the operator implemented, I think, is fairly easy. Handling the common cases, and then this is no different with Kubernetes than it is with anything else, but it's the edge cases that kill you, right? So.
Yeah, it's always hard. I mean, and getting deeper into the automation part of operators is hard too, because you can make it so that it'll deploy your thing and you can walk away. It'll set up the PVs and some networking. Yeah, sure. But then what's the day two? Day two is hard.
Day two operations are hard. That's correct. Yeah.
Mm-hmm.
I think that I could tell that you just want to grab the mic on this one.
Oh, I do.
Hold on, everyone. There's a rant coming.
It's not a rant. It's just it's Spark on Kubernetes. And I say it's a bad idea only because it's going to be frustrating if you try to do it at scale. If you're trying to do a terabyte, a few terabytes of data, it's probably going to be just fine. But it's not. Spark generally means more than a terabyte of data. It's probably, you're looking more like a petabyte of data. And the reasons, there's a couple of really key reasons, is that Spark expect certain things that Kubernetes was not designed for originally. For instance, these really bursty dynamic loads. So things that, when you start a Spark job, it'll be like, I want 10,000 nodes, please. All right. And then it'll throw them away in 10 minutes. And that will put etcd into an absolute panic.
Right. That's right.
The scheduler just isn't designed around this idea of how Spark wants to work. And Spark, for what it does, doesn't have any real awareness of Kubernetes either. So there's, you have these two opposing massive forces, facing each other. There's glimmers of hopes, and that's why I say, at least right now, I just noticed that there's a new project that went out of Sandbox and is being voted for incubation. It's called volcano.sh. And there's an ASF project called Unicorn with a Y, that is a new scheduler for like Spark workloads, and Flink, I believe, too. But this is not an unknown problem, and there are some active projects now thinking about how do we do this better. So if Spark on Kubernetes is a thing for you, there's some projects to get involved in.
Yes, and it gets down to, like you were saying, I think it gets down to the ability to handle scaling up and down the number of jobs that you have in the system really quickly. And it's funny because, Apache Mesos has basically gone into retirement. Mesos is a distributed compute platform, similar to Kubernetes, right? Similar goals. They were competing for a while, but Mesos was really good because it was designed to run Spark. So it was actually really good at handling those jobs. And, Kubernetes is kind of won out as the thing that we're all trying to deploy our workloads to now. It's just that, like you're saying, the scheduling piece has to mature. But the good news is it's pluggable, and the new schedulers are coming. And
yeah,
so this is one of those ways in which Kubernetes itself needs to mature, not just the data infrastructure.
yeah,
Man, I keep doing this. Like the next slide, just like elaborating my point. Wait, it's almost like we built this presentation to just flow. It's so good. So some of the other things that we noted are that it just takes, it's really about time and community. So Kubernetes is a really big open source project. And I think it's probably not totally surprising that like the bigger the open source community, the more special interest groups and subcommittees that you have, and kind of the more hurdles that you have to surmount in order to get changes into the actual project itself. So, you know, we've had some conversations about ideas like advanced stateful sets that there were some really cool things that you'll see that we talk about in the book. And you know why? And I was like naively asking, well, why can't advanced stateful sets just be a part of? Why can't those features be a part of stateful set, or why can't that be incorporated into the base Kubernetes API? And, you know, a series of conversations ensued in which I was shown that the error of my naivete about, you know, like what it takes to actually get things over the hump and get them incorporated into the project as a whole. So there are pros and cons to this, by the way. I don't know that we want a Kubernetes in which you know, APIs are fluctuating and changing back and forth all the time. But then at other times, it does feel like the pace of progress is maybe slower than it could be because, you know, we have these community governance things that kind of, I don't know, hold us in check. Do you want to riff on that before I advance?
No, I mean, well, and then I'll talk about the next slide like you did. No, I think this is an interesting thing about the project, and it's, you know, it'll change over time. But man, it's become so big, and it's cool and terrifying at the same time. But I have a lot of hope in like the way that the project is governed. The SIGs seem to be doing the right kinds of things. I like to see more activity in some of the SIGs. Like some of the SIGs is like emerged and then went dormant, and new SIGs are being created.
That's right.
Yeah. I'd like to see some of the original SIG applications seems to be the powerhouse of where a lot of stuff happens. And I'd love to see more activity in there.
Well, that is true. That is true. But it was interesting that, you know, finding someone to speak authoritatively on the history and current state of stateful sets is a little bit harder than I would have thought it would have been. Just to peel back the covers on the book writing process.
It was the person who's highly involved in SIG storage. Yeah. Oh, disaster recovery. Here we go.
All right. Is that orange for alert?
Yeah, and it's a different color. Warning, disaster recovery. Yeah, and this is everyone who's in ops that, you know, knows that DR and like time to recovery and all these things are really important metrics that you want to maintain. There's not a really clean story in Kubernetes, and that was one of the things we found out as we're talking to various groups. Like, you know, we're about like deploy and use a thing, and that's what people want to do. But then there's again the day two, and day two it seems to be a bigger problem because what happens? There was a question that was asked in one of our interviews. We were interviewing various people in the community in this book, and like, what happens when you destroy your Kubernetes cluster? Like, how bad is that for you? Because it's really easy to do. You could do that. I mean, if you use Lens, it's basically a right click. You could destroy your entire virtual data center in one shot. But how do you recover that? There's no control Z, there's no undo button. And that's a hard thing. Yeah. Jeff?
It's like Git.
Yeah, Git blame.
Just roll forward with a new commit. Just we're moving on.
Are you saying, so you're saying use Argo? Okay. Argo will fix it.
Okay. I think we're getting pretty close to our list of the things that we learned, the broad conclusions that we have arrived at from our investigations so far. One of the things that we're trying to do in this book, and you'll have to be the judge of how successful we are, but we are trying to have a narrative to try to tell a story, starting from first principles and building up things. But one of the main pieces of the story that we're trying to tell is this idea that there's a maturation that's taking place in Kubernetes and in the data and Kubernetes community. The changes that we're trying to make things better, definitely celebrating all that we've accomplished so far, but then also looking forward to what actually needs to happen. So if it works the way I think, one of the things that you'll see is these interviews that we have scattered throughout the book from various people within this community and thought leaders within this community is an ongoing conversation where you'll see them in these interviews making a lot of the same points, and that's not lost on us, and hopefully it won't be lost on you. So one of the key conversations that started to emerge as we've been going through the chapters is this idea that we love the abstractions that Kubernetes gives us, right? Persistent volumes, PVCs, stateful sets, those are great. Those are great building blocks. Now we actually need some higher level ones. So you'll see some arguments like, why does every database operator define its own custom resource, provide its own custom resource definition, or CRD, for backup and restore? Shouldn't there just be like a common language for backup and restores in terms of resources on Kubernetes? There's N more examples like that of maybe we really do need to start having some conversations about higher level of abstractions that could be in common. And then, each database or each streaming platform could provide its own implementations based on a common set of resource definitions. Could we really get there?
We had custom definitions that were part of, that we could add to YAML files, that extend the object model of Kubernetes. But
right.
I hope that we can get to some more formalisms, like ingress, for instance. Can we get into a data services? And I think in the storage world, there's like classifying certain data storage. Like, is this long-term slow and cheap, or is this
right,
high speed fast, that sort of thing? So yeah, I hope we get there. Go ahead.
No. Okay, not jumping the gun. So this is where we're going to kind of turn the page over to your questions here in just a second. We've had a good number of people that have reached out to us. Bart, you've done such an awesome job of helping make connections between some interested folks and helping us get together with them. So here are the concrete ways in which we could use help. And we're really, we want this to be a book, like this book is a love letter to this community. It is. And hopefully, by virtue of the fact that we're getting inputs from you and doing interviews with community members, there's a lot of voices that are coming into this that are not just our voices. So we have a repo on GitHub. It's Data on Kate's book. You can see the URL there, and there's two repos in this GitHub org. One of them is called Outline, and the other one is called Examples. So, like, it's pretty basic. The examples is the actual source code examples that we're using in the book. A lot of them are unashamedly borrowed or cloned, aggregated from other repos for different technologies, but we're trying to provide like a point in time snapshot of this is the example that we used in the book, and then we will try to keep in sync with some of the upstream projects that we're tracking for those. I think that what we have right now in the examples repo is mostly focused on like just getting started examples with each technology. We're definitely open to having more complicated examples. That's probably more than we have time to totally build ourselves just for this book project, given everything that's involved in it. But if there is interest in kind of growing out a broader set of examples, we would totally be down for some pull requests in that regard. And then with respect to the outline, I'm going to make a little bit of a confession here. I think it's okay to make. When Patrick and I pitched this book, the first half of the outline I felt was really solid. And like known quantity. And then the further we got, the closer that we got to the end of the outline, the more speculative it felt. And so we're about to, basically, we're each writing right now the last chapter that we feel totally solid about what the content is going to be. So I'm writing 7 and Patrick's writing 8. I'm writing about broader, kind of building broader stacks of technology, and Patrick, you're writing about analytics and
I am writing
nightmare
a lot about analytics right now
that you shared back a couple of slides ago. But after that, the outline gets a little more speculative, and so we're actually within the next couple of weeks here about to have a little bit of a powwow to review what we put out there for the outline originally and say, is this still right? So this would be a perfect time for us to get some input about areas that we've kind of talked about writing about, but don't have a lot of data yet, like declarative data, like building data pipelines, like ML and AI workflows. Any other of those speculative things that you want to mention?
I don't know if I really want to get into too much. I want to hear. I don't want to tip.
I just try to put a couple things out there as seeds. Those aren't meant as limiting. Yeah. Those are the jumping off point.
Yeah, I think there's definitely. I see in the questions, there's a lot of people that are asking about more comprehensiveness of, deploying data, like a whole entire data stack, application stack, using everything.
Right.
And that does seem. I think that's the next frontier for sure. Like I said, we do a lot of databases, but if you bring streaming analytics and database into a single application, which most are now, how do you do that?
And that's a little bit of a sneak preview, is that we're probably not going to just pick winners and just say, here's the one stack. You should use this database with this streaming, with this analytics, with this ML. It's not really about picking a winner stack, right? Because everyone's inevitably going to end up with a different stack that they need to build. What we're going for is more like, how do you go about it? What are the principles?
I think this is a good opportunity for us to answer some questions, because I see some of the questions are already in here and they kind of go into this. So maybe we just jump into it. Do it. Bart, do you want to take it from the top, or do you want to be the questioner? Or do you want me to
but also, I'll just start with the first couple, just for, kind of background, folks that are approaching this at different points, different organizations, different challenges. So, and particularly because you touched on this in the beginning is, so what's the first step to running data in Kubernetes? Let's start, I think, trying to get those, get our prepositions right. So with that in mind, from a mentality perspective, Patrick, you gave that great talk about from DBA to SRE, but when organizations are going to be approaching this for the first time, what are resources they should consult, things that they might need to unlearn? I know it's kind of a big question, but just thinking in a very practical sense, obviously join the Data on Kubernetes community, but what would you advise?
I was going to say that.
Damn it. Sorry.
Man. Teed me up.
Are you going to answer that, Jeff? Or
the other thing I was going to say is read our book, but that sounds way too self-serving.
No, buy your book.
You don't have to buy it. You can just go download.
We'll get the free one.
That's true. Get the free. No, yeah, don't buy it. Get the free version. Yeah, don't buy it. Anyway, Jeff, but how would you approach that? Just like, quick answer for anybody who's, wants to get started on this, you'd say, well, if I had to choose one thing, you would definitely want to keep this in mind.
I think that I approach problems like these like a piece at a time. Like I think one of the marks of a a more mature developer, or at least me personally in my journey as a developer, is like, I used to think that maybe I would just like write the whole application and just deploy it, and then it's all going to work. I mean, with technologies like this, you really do need to kind of build a piece at a time and layer on it. Hopefully this community is helping to give the tools so that you can get those quick starts and just kind of layer in a little piece at a time. So like concrete example, I think that you should endeavor to have at least a rudimentary understanding of how storage on Kubernetes works before you just go deploying databases. Now, I would love to get to a world, and you can counter me too, Patrick. There's a counterpoint to how to be sure. Like, yes, I would love it if deploying a database was just like, hey, here's some YAML, deploy the database and go. But I think in turn, if we're concerned about having the skill sets where we're actually maintaining applications in Kubernetes, we should understand the primitives. That's my point. Okay, now tell me why I'm wrong.
I don't think you're wrong, but I think if someone's just getting started on Kubernetes, you absolutely should not run your own Kubernetes. That is the wrong way to do it. I firmly believe that Kubernetes will be a service that's provided. Like every cloud now has a Kubernetes service, and I think that's perfectly legit right now. That's the way forward. Do you want to be in the business of being a Kubernetes admin, or in the business of being an SRE that knows how to use Kubernetes to make the thing that you want work? Like, for instance, your application that actually makes money. And you could use kind, if you want to do K3S, something like that, that's local, and sure, you will learn a lot of things, but is that a practical piece of knowledge? I think in 2022, no, it's not. It's useful and interesting for lots of things, but probably not going to be the path forward for you to know how to do what you like, be an SRE.
Good. One other thing, this is a purely aesthetic question. Can you stop sharing your screen so we can see you in full view?
Yeah.
Oh, wait a minute. That's a lot.
Yeah. Okay, good.
That's a really good call.
Next question. What is the efficiency aspect of running data, let's say in Kubernetes? There are many aspects of serving data, and how are they affected by running our data in Kubernetes? Also, could you give a brief comparison between the efficiency of running data regularly and running data in Kubernetes?
The regular way, the standard
fashion. Standard. Yeah, the Starbucks way. Yeah,
the Starbucks way. Yeah, like I'm assuming we're talking about bare metal, like buying a physical server and installing a database on it. That can seem efficient because, wow, I just dedicated this entire huge honking machine to running my database. That's great. The downside is whenever you need to start doing, like moving things around or changing your infrastructure. The efficiencies that I see that you running a database on Kubernetes is in everything around it. No database stands alone. Everything's a part of an ecosystem, an application stack. And getting into that, like when you're building a virtual data center, the efficiency of running, that database there is that now you have the ability to maintain security by default. You can use things like Cert Manager to maintain your service or TLS certificates. All those little things there that just you think about. Like I used to have I ran infrastructure for a long time, and I had a security team. And we had a networking team. All these things, now you don't need them. They're part of it. I think also in with certain kinds of databases, like one of the things that Jeff and I both work on is Cassandra, which if you've run Cassandra the regular way, you will become an expert at running Cassandra, which probably you don't need to do there anymore. Cassandra, you just helm install Cassandra, and it does so many things for you. Even does like day 2 ops, like running repairs and doing backups and things like that. That is a huge time savings. And if you're not getting that out of what you're doing, then you should do something different, because you should see more efficiency in the end.
Very, very good. Next question. Given proficiency over Kubernetes architecture, how hard is it to implement operators using stateful sets for various databases? What are some essential dependencies, and what are a few best practices which developers must keep in mind?
This is right up your alley, Jeff.
Do it,
Oh my
Jeff.
goodness! Wow.
Go for it, Jeff. Attack.
So I think that there's some emerging expertise in frameworks and in terms of writing good operators. So the operator framework is out there. There's also Kube Builder. So some of the things like I'm going to plug some stuff like these two books were really good. When I was writing the operators chapter, the Kubernetes operators, this is a good high level description of what, yes, I'm an old school. Don't judge me. I buy real books on real paper and don't just read everything on Safari. Quit judging me.
Tree killer.
And then programming Kubernetes, this gets down into the low level stuff. Like if you want to learn how to write controllers in Go, this is a really good book. So in terms of resources, I think these are how you get good. I would say that going and looking at other open source projects, it's more accessible than I would have thought. So like, as I've been writing lately, I've been diving into source code for Cassandra operator and Cass operator, which kind of Cassandra operator builds on top of Cass operator. So just finding a legit operator that you can use as an example to help pull some programming patterns and best patterns. And then, like I said, operator framework, reading some of the literature. This is my advice.
Good. You got some support too from people that read real books. That's good.
Okay,
It's good. Moral support. That's good too.
How do you search? I don't get it.
That's a good.
Okay. So I do. This is funny because I have the Safari account. I am kind of a hybrid user where I just process information better off of the written page, and then I go back and search for it later on Safari. So yeah.
Okay. All right. So hybrid model. That's all right. Good. Now, all right. Another question here. At what point does running data on Kubernetes become overkill? Like, how do I know when I should migrate my stateful workloads to Kubernetes? Is there a metric for that? For example, DAU?
I'm going to make a statement that I haven't thought about. I'm going to postulate a thesis, and then we can look at it and examine it together. Because I don't know if it's right yet, but it just occurred to me, which is, I don't know if it's a lot different than deciding that your app is ready to be deployed on Kubernetes. I think there's two worlds. There's a world of, hey, I'm just kind of getting started, and how do I know when I need to adopt Kubernetes when I'm like at the scale? I don't know that the database is a determining factor that would be a lot different than should your application is that traffic ready enough for it to be deployed on Kubernetes? But the other thing is, there's probably also shops that I could think of in the world where basically everything goes on Kubernetes regardless of scale, because this is where we deploy things. And so in that case, maybe it's not even a question. So I don't know how to say how many daily active users or something, or what scale your application needs to be to go on Kubernetes. I'm just saying that I don't think that the data part makes it a lot different.
All right. Patrick, anything you want to
add? Yeah, well, see, here's a couple of things that you should also consider is, Kubernetes doesn't always mean deploying absolutely everything by yourself. You can still be quite cloud native and Kubernetes by using services as well. For instance, if you're using OpenShift, which is a Red Hat service, they allow you to connect to various services. So you don't have to think of it's all or nothing. It can be quite hybridized and be okay that way. There's databases as a service like DataStax. We sell a Cassandra as a service, which can integrate with your Kubernetes installation. There are, services for analytics, for streaming, all these different components that you don't have to do everything. If you just want to stick to, say, like your microservices or application stack, that's fine to start with. But eventually, I mean, it's just going to come down to your personal preferences. Like, how much do you really think you want to do? And I'm going to go back and just push the idea, don't run. You could deploy anything in a cloud Kubernetes service, and it's really easy. Like Google has this, so easy to set up. You want to run a WordPress blog on Kubernetes using the Google Kubernetes service. It's super easy, and it's actually cheaper because, think about using Kubernetes, the Kubernetes services in this regard. And now does your answer change?
All right. Next question. Implementing abstract CRDs has more to do with the way the database is developed and implemented, right? Like, would it be fair for abstracting databases that are implemented in different ways, or am I missing something here?
So let me jump in on this one again. One of the theories, and this a lot of this came out of conversation with Umair. A lot of databases are going to have very specific things that are kind of peculiar to them, but then there are some common concepts across databases. So like, if you think about the way that most relational databases are going to work with concepts of primary and secondary replicas, and basically the ways in which topologies of those databases are represented, I think there's a strong case to be made that we could have a unified language of custom resources in Kubernetes to represent database topology, or cluster, relational database cluster topology. I think that we have a good shot at being able to do something like that. Now, there might be some peculiarities, like Cassandra, the fact that it has this repair mechanism that's probably going to be pretty unique to Cassandra, and there's not going to be a lot of value. Just to take, like, I don't know, like kind of an obvious trivial example, right? No, there's not some common representation of database maintenance operations that we can just abstract away. But at least stuff like topology is a little more concrete, and I think we can.
All right, good. Next question. All right, so this might put you in a little bit of a bind, Patrick, but it's your birthday. So what is your opinion about using traffic with stateful workloads? Does it make the process a teeny bit complicated, or is it simpler? And if so, how?
Traffic. Well, as a traffic ambassador. Actually,
I have to modestly preface my statement.
Yeah, so let me just tell you.
Do they call it? They should call their community advocates cops.
Like cops, yeah, traffic cops, yeah. That's what I want to be.
It's free.
Like, I just tweet, like, go ahead, turn right. Traffic is one of many ingress tools that makes a lot of these kind of things easier, because it sets up these layers of abstraction that you need in your virtual data center. I mean, if you're doing this in Amazon, you'd probably want to have a load balancer of some sort, or reverse proxy. I think the things that like a tool like Traffic brings, which a lot of people don't even think about, is that it also makes using TLS certificates really easy too. Just the fact that it manages the certificate, does the renewals, and then all your traffic is going through the single point, like a reverse proxy, that they're always going to be, they're going to be encrypted. These are all great, and it just gives you a level of control that you don't normally expect whenever you deploy things. It's a tool you need to get to know really well. Traffic is really well documented. It has a lot of good stuff in it, and it does some really cool things. But just giving everyone else fair hearing, Nginx is, the basic ingress tool is pretty amazing for everything that it can do. Using load balancers and again, using a service like a load balancer from the cloud also does that. So, I'd say these are probably a very critical part of your arsenal, but not, and if you're just learning, maybe not the most important thing. Jeff, what do you think?
Hey, let me devil's advocate for 1 second here.
Sure.
Why do we need an ingress for our data on Kubernetes? Because aren't we deploying our app? And like when I hear ingress, we're talking about like getting data out of Kubernetes. So, I mean, aren't most architectures going to have a application that's deployed on top of our data that's running in Kubernetes? And doesn't the application layer, that's the one that really has to worry about ingress with traffic or Nginx? Like who's exposing database access directly using traffic?
It can happen
Outside of
sure.
Kubernetes.
Yeah, but I think there's a lot of data APIs that get exposed, and this is probably a side effect of the issue that we have trouble doing multiple data center, multiple cluster Kubernetes. Every Kubernetes cluster is an island. So this is one of my favorite things when someone fires up their first Kubernetes cluster is, how do I get in it? There's like, all the stuff is in there running. I see it. I say,
port forward.
I'm doing kubectl on my pods and they're all there, but how do I even get to them? I don't even know what to do. And it's like, that's Kubernetes saying you're welcome. We set up all the security. Yeah, secure by default. And you're right. I would argue that most times you probably don't, but it can also do it can do internal from namespace to namespace, or you can abstract it. You can do internally. You can move traffic around inside of your virtual, like, let's see how big your virtual data center is. Well, if you have your microservices running over here, and you have your database running over there, internally, what does that get you? Well, you also have a way to manage those TLS, like MTLS, being able to do encryption both ways. So sure, there's a reason to do that.
All right, good.
Like
advanced user topic for sure.
All right. So yeah, we got traffic cops and traffic criminals. Looking at we only got a couple minutes left, but just to touch on one of the, I'm gonna mix two questions here because I think they kind of touch on similar topics. Given that we have distributed or replicated database servers, how is data consistency maintained? And then by extension, how is the system where all other workloads except databases are running in Kubernetes maintained?
Go ahead, Jeff.
Oh man, I kept jumping in first on questions. You're like totally conditioned to that, right? So so there's two parts to it there. Okay, so
we can
for one thing, like the data technology that you're using has its own way of handling consistency. So that's not going to change by virtue of running or deploying in Kubernetes, right? So like Cassandra, it's an eventually consistent system. You're going to deploy it. It's going to work the same way outside of Kubernetes that it is inside Kubernetes. That's a property of the data technology that you're choosing, is the way it handles consistency, that I think is unaffected by Kubernetes. What was the second part of the question?
1 second, let me get to that. So here we go. How is a system where all other workloads except databases are running in Kubernetes maintained?
Okay. How is it maintained? I just want to make sure I'm getting the nuance of the question, because I think we had something kind of like this before, when we were talking. Patrick was talking about kind of like deploying your database on bare metal, and what are some of the efficiencies or inefficiencies?
I got you. Yeah. No, that's pretty much all it says. And this was asked previously, so I'm not sure if this community member is here live. But like you said, it was addressed previously. Anyway, no, we're right on time to finish up. But I think this was very good. I'm glad we did this. I think it's a reminder that we got okay. Does Kubernetes fix the CAP theorem if implemented in the correct way?
No.
Short answer.
That's like, no, wait, I built a perpetual motion machine using Kubernetes.
There is no magic.
There is no magic. No, CAP theorem is still in play. And this is the thing you have to remember, is that CAP theorem doesn't get fixed by better architectures. the CAP theorem just helps you manage any architecture. It's a way to conceptualize
It's a
how
yeah,
your
a
database
reasoning tool.
reacts. Yeah. So if you're using a CP database, then you know that your database will react to certain changes in your architecture. If you're using an AP database, it will react differently, but in some cases better in larger changes. There's just more resilience to change in AP databases. That's why they're popular for what they are. There's a lot to be said around CAP theorem and whether or not that if we have moved on, but until we've figured out faster than light communication, no.
All right. So let's figure out faster than light communication, and then we'll work on that.
I gotta work.
Step one, faster than light communication.
Yeah,
Step two,
all right,
world domination.
All right.
Quantum entangled bits.
We've got that laid out. All right. This is, like I said, a very, very productive session. We still got a couple of questions, but I think they can be answered on Slack. A couple of things.
Step three, Steel Moon.
So thanks everyone for joining us. Thanks for all the folks that submitted questions previously as well. Great presentation. Get the free version of the book. Don't pay for it. Or pay for it and support a worthy cause. You'll be hearing more about this as we get in KubeCon for sure and around that time. But there will definitely be more news coming out about that. If you want to get involved in the book, if you have questions, if you have criticism, if you have ideas, feedback, etc., we already dropped a link to the GitHub for the Data on Kate's book. All right, so you can check that out. Also, Jeff and Patrick are very accessible in Slack, so you can always reach out there. Thank you both so much for your time today, particularly on your birthday, Patrick. This is
where else would I want to be? Hang out with my friends.
That's true. This is the first, hopefully not the last time we're celebrating a birthday in a live stream. As usual, we've got our man behind the scenes, Angel, who's creating amazing artwork. So let me know when you can see this. We also got the birthday theme in there too. Very important. Very important.
This is awesome.
we talked about lots of cool stuff today. Great presentation, awesome slides, good questions from the audience. Keep the questions coming. All right. Jeff and Patrick, really just that's what they're all about, is answering questions.
I love the happy birthday cake. That is amazing.
I know. I kind of want to have a cake. Yeah. Oh, and we got your O'Reilly bird in there too.
My book plug.
That's good.
Hey, I was wearing a DoK shirt today.
No, massive respect. We know Jeff's wearing his underneath his hooded sweatshirt.
Yeah. So we need DoK hoodies.
we can get those for KubeCon. All right. Anyway, thanks very much. Thanks so much to everyone. We'll have more live streams coming up next week. Plenty of content coming out as usual. Let's keep the conversations going on Slack. Jeff and Patrick, thank you so much for all your contributions today. And we'll keep this moving. All right. Thanks a lot, everybody. Take care.
See you.